Can you see the presentation now?
We can see the presentation.
Yep.
We cannot see you.
Fine.
Yeah.
Okay, you should be able to see me because I see myself in the. So this depends on the layout of Zoom. If you have problems, yeah. Does anybody has problems with? Is anybody having problem with the?
All good. All good now.
All good. Perfect. All right. So before we start, few remarks. So don't be afraid of missing some information because we have the link to the presentation first, and secondly, everything is recorded. So later on, the workshop video will be available on the Fab Foundation channel on YouTube. So before we start, some other notes about the workshop itself. So this will be more of an open discussion, so you will not need to use any tool. It will be basically showing our activities in documenting. You will see sometime on the bottom left of each slide a QR code. So these QR codes points to something that is relative to the slide. So for example, this one especially points to the slides itself. You will find more QR codes for the software used, links, tutorials, and so on. Other than that, please feel free to interrupt me anytime in case you have questions, because this is sort of really open discussion to everybody. And so this open discussion will be divided in 3 different sections. The first section is to show you the past experiences in making documentation. Then the second section is about presenting you how we did document our small laser cutter machine, Fabulaser. And then the third session is an open discussion where we will ask you some questions, or we can openly discuss about what's your way of documenting, how do you see documentation in the future, and so on. So I think it's very important to note that the diffusion of almost all open source projects relies on documentation. And even though we are, me personally at least, very passionate about building hardware, if something is not documented, it's like that never happened. And especially like not everybody will be able to replicate it. So I think it's very important to not only develop the hardware, but also to make the documentation for it. So I think almost everybody in this workshop knows me very well. So my name is Daniele Ingrassia. I'm in the world of Fab Labs since 2015. In the past, I was working as a computer scientist in a big company in Italy, till I had the chance to do Fab Academy. I was passionate at building things at home in the weekends, and my company sponsored for me the Fab Academy. So at that time, I was not aware of all this world of making. I was not aware of what Fab Labs can do, what is Fab Academy, and so on. And after attending Fab Academy, I decided to quit my old job and to join the world of Fab Labs, because I got really catched up with all the possibilities. So here are some of my works. I'm famous because I made a long time ago lots of open source PCBs. I work with drones and build machines and so on. So till that time, I did join the Fab Lab community. So I have been traveling a lot and meeting almost all of you guys that are in this call, students, other instructors, and so on. And I have to say that this is some kind of new family of new colleagues, or it's a worldwide distributed, let's say, team that I always encourage to develop new things and exchange ideas and so on. So we will start with the first documentation approaches. These documentation approaches are based on my first experiences in documentation, and I have to add new people. All right, yeah. And in this picture, you can see a drone workshop that I was running some time ago. And the documentation was crucial at that time to let people replicate the drone. So the first documentation that I made was when I was a programmer, and was to document software. So I don't know if any of you has ever worked with these very specialized tools, such as, for example, Unified Modeling Language, which is a language to model a software system. which consists of different objects, and the objects that have a relation between each other, which can be contains, for example, is in this case in the image present by, started by, initiated by, blah, blah, and so on. And then it would also list the kind of attributes that each object in object-oriented programming has, and functions that the object have, and so on. So basically, in this case, you can see the structure of your software. So many of the things that you see on this slide have been generated semi-automatically, meaning that while you develop the software, you can add some sort of tags or additional comments to generate these graphs and these things automatically. On top, you can see, for example, Javadoc, which is generating HTML documentation about the software, the application programming interface of the software automatically by analyzing the tags in the code directly. I was also using database in the past to document things, to create like special relationships that were not defined in either, for example, Javadoc or in UML, which was a graph database. So I was creating like basically nodes. I was creating my own relationship between the nodes. For example, if something belongs to something else, or if it's eponymous or hyperonymus, for example, is container or contains. And then I was taking a screenshot of this graph and then documenting the different objects. This was especially useful in case of, for example, of ontologies, or taxonomies, or basically hierarchies and categories of different things. Past that, I started with Fab Academy in 2015, and at that time we didn't have Git or Gitlab platform. We didn't have our beautiful template that Fiore did, that is using Markdown. And so basically I was using HTML all the way. So I was, as many other students, taking a template and modifying the template. And my tools were basically HTML editors, such as Sublime. I was running Fab Academy completely on Linux Mint. Therefore, I was forced to use some software that runs on Linux and then use a virtual machine for other software. And my other third tool that I was using was basically Inkscape, that I used to make different schemas of objects and so on. So this was my first approach in documentation. I have to say that although I wrote 16 pages for my final project, and now my documentation is still very useful because I can see that it's full of information that I always consult. It is really far from what we're doing now or the way that I'm documenting now. Okay, so I think you need some experience also to let the process be completely replicable in terms of what is needed, in terms of information, in terms of steps, also in terms of experience of making the thing. So this was, for example, my first time in making circuit boards, and I had a lot of difficulties. And nowadays, my circuit boards would have been different, and my documentation would have been different as well. All right, along the years in Fab Academy, I developed lots of open source electronics boards that have been all published on GitHub online. And this was also the chance to start documenting something different from Fab Academy. So in 2015, during my Fab Academy, I also published the documentation of my microcontroller board. And at that time, there weren't many boards or boards at all in Fab Academy, which they had all the pinouts, all the connection schemas, all the fabrication files ready to be downloaded. So now these files are mandatory to be uploaded from the students. But at that time, you know, there were just maybe the Eagle file. So what I brought was a complete pinout in the layout of the boards, the complete files, the complete instruction on how to connect things, and the step-by-step instruction on how to program them, how to use everything, and so on. So in this case, one of the difficulties we had was the conversion between the pinout, the low-level pinouts, for example, the ports of the microcontroller, and the pinout of the Arduino bootloader, where you have, for example, the numbers of the Arduino libraries. So, and this caused always a lot of confusion. So, and another point was that I wasn't hosting this documentation only inside the Fab Academy repository. At that time, that was made in Mercurial. I was hosting this documentation also outside. So, and it was kind of a stable because along the years, many links in Fab Academy also changed and were sometimes also not reachable anymore. So this approach to document that was in first instance needed for my colleagues in my Fab Lab to be able to go on with electronics and Fab Academy led to a lot of replication of the Sasha kits. So if you search Sasha kit in Fab Academy, still now it's sort of obsolete because it uses the old microcontrollers, but still I've seen people using it this cycle. And you can see there are lots of different replications, and I have to say that people was very honest in mentioning the source of the project, and also they were adding lots of modifications to the board. So the community was firing back lots of improvements and additions to this board. So, and therefore this gave me a big push about documenting things more and more detailed in a way that people can use this documentation to replicate the boards. So then I was also making several drones in Fab Academy, and also these drones were used in workshops for people to replicate them. And then I was also creating documentation for these drones. So I developed different drones, from small ones to big ones, and every of these drones has its own documentation in a separate page. All right. So the documentation of the drone was a little bit different from the electronics, because since the document electronics, you just need pinouts. You almost don't need much of a physical assembly, just the position of the components. So in this case, in this documentation, I had to deal with physical assembly. And not only with that, because this was targeted to a workshop, I had to deal. I started to deal with time constraints. So how long is needed to make this drone? How long is needed for people to replicate it? Also people, for example, without experience. So in this case, this documentation was targeted to a workshop of 3 days. And then for each day, there were different activities. Worth to be mentioned that in this workshop, people were supposed to solder the PCB on their own, not to fabricate anything, but to solder the PCB on their own. And then they were supposed also to assemble the drone physically and to test it. Okay, so drones can also be dangerous. So there is a section of this manual dedicated to how you should start testing the drone, being far away, for example, the position of the remote controller, and so on. So I have to say this documentation was really successful, but it needed me as a support for people to replicate the drone. So this documentation was used, let's say in a workshop where, for example, 10 people would read the documentation and I could follow maybe one person per time. It was a sort of support to the workshop. But was, I think, not enough alone for people to completely replicate the drone, unless people had some experience in the drone itself. So the way that this documentation is made, so the documentation of the Sasha kit was made on GitHub using Markdown. This documentation was made directly in Google Docs, and it was easy for me because I was drag and dropping all the pictures, and I was creating automatically the index and so on, and then I exported it as PDF and uploaded it into the repository. All right, the next step was for me to document machines. And as you can see in this GIF, machines have a lot of parts, and also they include lots of complex assembly and calibrations and so on. And this was sort of a step further of documenting the Sasha kit or of documenting the drone. So the first machine that I was documenting was Laserduo, which is a large laser cutter, which uses 2 laser sources to work. So for who is interested in knowing more about machines, there's going to be a workshop next Thursday, 9:30 AM, chest time, where we will talk more about the machine. So this was my first approach in making machines. And I have to say it was a little bit of a too big machine as a first try. And also the documentation for this was very difficult to make. So the documentation in this case consisted in uploading all the files and all information to GitHub. In this case, we are not only talking about the PCB or some schematics or some simple files. We are talking about complete CAD file, all the electronics files. And then I also created an assembly manual for the building of this machine. So it was, for me, the first time to create such a complex assembly manual. You have to know that developing hardware is already very hard. And making on top the documentation, it's something extra. So you will see in the future, I found another solution to make the documentation, which is basically outsourcing and involving other people in the team to make it. So for now, I was doing it using, in this case, Google Slides and taking screenshots directly from the CAD. And for each step of the assembly, I was defining the materials, the notes that people should take care of. And I was also taking care of separating like the things that should be assembled and so on. So this was still a very basic way of documenting, but at least it had some structure because in this case we have the materials that we need, we have some nodes, and things were divided more in steps. So the documentation again was not enough for people to completely replicate this machine. Also because I have to say this machine is expensive and difficult. You need big machines to fabricate the parts and so on. But at least it served again as a support for a workshop, which I did run 3 years ago in Hamburg. And the students were able to completely replicate the machine, of course, also with my support. So then I also documented the Big FADM, which is a large-scale 3D printer that I built while I was working in Dubai. So this machine is way less complex than Laserduo. It has a printing area of almost 1 cubic meter, but it involves mainly the basic components of a 3D printer. So a motion in 3 axes and electronics to drive the extruders and to warm up the hot hands and so on. So in this case, my approach to documentation was also meant to be used in a workshop, which was successful. And in this case, I was directly using the wiki from GitHub. So you know that in each repository, you can have a sort of wiki where you can describe your project. This wiki works in Markdown, so you can use your Markdown text to write your documentation. And I was following a similar structure to what I did with Laserduo, but I had much more text about what the procedure to assemble the things should be. So in this case, I was also still adding pictures from the CAD. And then I was having a list of tools required, machine parts required, and so on. So this documentation was way easier to see because it was directly in the wiki of the repository. So people don't have to download a PDF or can easily copy the text and copy the images and so on. All right, then I was also documenting a lot using platforms. So that's another way of documenting. So there are different platforms like Hackaday, Instructables, and different wikis that are like open up for people to easily document, I would say. And I was basically transporting or migrating different projects that I did in the past, like Laserduo or Big FADM to this platform. And I have to say that they are way easier to use in comparison with writing HTML or writing Markdown. And are also easy in terms of importing projects from other platforms. So in these platforms, you can import projects from GitHub, for example, directly, and they will try to, let's say, match everything that you wrote in terms of, for example, positioning style, layouting, and so on, of course, with some small differences. So one example is, for example, Hackaday. I don't know if you have tried this platform. Is basically having a sort of form, a guided form online where you put, for example, the title, the files, and everything. And then this results in a single page document where your project is explained. This was, for example, imported from GitHub, which was done in Markdown. And this created automatically the index of the page. And then scrolling down, you can see the different sections of the documentation. And at the end, you can download the code. What I don't like of these platforms is that they use some kind of then, let's say, proprietary changes of the format. And also they throw at you a lot of publicity. So if you go to their website, you will see it listed on the side of your project and so on, which is not happening, of course, if you go to platforms like GitHub. Another example was Hackaday, which is a little bit more structured than Hackster, I have to say, because at least you have these hyperlinks where you can define the different sections of the documentation. And you have a section, for example, for the files and so on. Another thing that people can do in this platform is, of course, commenting. And, commenting here is much more easy to, in comparison to open an issue, for example, or making a pull request in GitHub. So people here can directly comment if they have an account and so on. So another platform that is very well used and known is, of course, Instructables. In this case, I couldn't import my project directly from GitHub or GitLab, but I was basically copying and pasting the text and the picture. So one advanced points of a good point of Instructables is that this was very, very easy to use. So you have basically everything already divided in steps, which was not the case of Hackster or Hackaday. And what you do for each step is you add the pictures, and then you just add the text and the file. So each step is consistent in terms of media and files that it needs. And then you basically stack up multiple steps, and boom, you have your documentation. So I have to say this way, it's really easy for people, but it's also very, very, very limited. So you cannot do many things in Instructables, and pictures are not distributed along the text, but they are all stacked in the top. So basically, if people want to see all the picture of that step, you have to browse the pictures, and you cannot put the picture like how you would do it in your own documentation, but they are connected to a specific section of the text. All right, so these platforms, they also implement, let's say, more social features than Git or GitLab. I mean, in GitLab or GitHub, you have basically the star, but here you have featured, you have like the hearts. You can participate to contests and many other activities made by this. So they had more about also the social activities in the documentation. You don't need to be an expert to join. All right, then I was trying different kind of wikis. So wikis are based on the concept of a similar concept of Wikipedia, where you basically have a page that that you can use to document something, and you have basically also a software that runs on a server that expose these pages into a website. So you're going to have to do your documentation on a standalone website. And you have many different kinds of wikis. You have standalone wikis, like we will see DokuWiki, for example, or you have wikis that are integrated into GitLab or GitHub. So I was already talking about the wiki in GitHub. In this case, for example, last year in our Fab Lab, we were using the wiki from GitLab. So the wiki from GitLab is quite intuitive, and recently they also had a real-time preview of the markdown that you're writing. And in this preview, you can write the text as it was directly like in Word, or what you see is what you get, like a sort of text editor. And it supports Markdown, although it has some changes from the standard Markdown and some enhancements as well of the standard Markdown. And we were using this to create the wiki of our Fab Lab, to document basically the boards that we were making, the tutorials, the procedures to use the machines, and so on. The nice thing about this is that it was coming for free into our GitLab installation. So we were able to install this in our servers in our university. And then we were able to manage this wiki on our own. So we could do whatever we like. We don't have to use another platform that is existing on another server, like, for example, the wiki from GitHub. Another wiki that we are recently using is DokuWiki. This wiki is completely standalone, which means it's not attached to any other platform. You can install it into your own server, and it uses a sort of specific syntax. which is not entirely related to Markdown. Some things might be similar, but many others are completely different. This is something that I don't like, that you're forced to use another language to use this wiki. But one advantage of this is that it's really modular and you can expand it because it has lots of plugins. And for example, you can have plugins for tables, plugins for videos, plugins for calendar, which will send you a reminder. So it's really something that you can expand, and modularly you can shape it the way you want. So now, for example, this is the tool that we use in our Fab Lab to create the documentation about our project. It has also a preview function that you can see here. So you have on top the text, the syntax, and then on the bottom you have basically the preview of what you're going to write. There are some simplified procedures, for example, to add a picture, to add a link, and so on. So if you don't remember the syntax, you can click these buttons here on top, and then this will create for you automatically the link. All right, and this was documenting with the wikis, and then I was trying also some other software to make documentation this more recently. And I discovered this, for example, kind of documentation is used also in some classes from Neil. For example, the machine class, or how to make almost anything, the MIT, and it's called Jekyll. So Jekyll is basically a blog generator system that will allow you to write files in Markdown and will automatically generate HTML out of it. And then you can deploy the HTML directly into your web server, and you have basically your web page. So it's also highly modular, and you can customize it. There are different templates. For example, I was downloading Jekyll and then a template, and then you can see on the left Visual Studio Code. And then you have, for example, different entry in the block. So I was creating an entry for introduction, for example, work in progress, previous works, and so on. And then for each of these, I could mix HTML and Markdown together, writing some metadata on the top, like the title, category, tags, and so on. And then this would automatically generate the HTML on the right. So it works by command line. You just launch Jekyll serve, and it will automatically deploy the code. It's worth to mention that the changes to the codes are automatically deployed. So once you make a change into the Markdown files, it will be automatically deployed onto the file or onto the website. So you can basically see it directly if you see it locally. So I found this quite similar to the template that we were using for Fab Academy in terms of content of the single pages. Of course, the organization is a little bit different, but also here you can create different, let's say, menus and links to different sections of the blogs or different blog entries and so on. So with these guys, I was able to create a page resuming all my work in like one afternoon. So it was very quick for me and very fast. And something to mention about also Visual Studio Code. So I was used to use Visual Studio in 2008 or something like that. And at that time was a Windows-only program. It was closed source, but now it has become open source and runs in all the operating systems. And it integrates also the workflow with Git, so you can pull, push, and commit with Visual Studio Code. And I found it very useful to write Markdown. So it has lots of plugins. You can see the preview, the Markdown, or the HTML. It has auto-completion and lots of other standard features of integrated development environments. So in case you would like to write some, for example, Markdown or HTML code locally, I highly recommend Visual Studio Code. I'm also using it to edit, for example, the C files for the microcontrollers and all bunch of other kind of code. So it's like only one tool. All right, and with this, we ended the part about the documentation with platforms and all my experiences in documentation that I've made in the past. So Fabulaser Mini is a small laser cutter that we are currently making. And it's basically meant for schools with a cutting area of 600 by 400 and a 40-watt laser tube. It can cut traditional materials that you can cut with CO2 laser. So for many reasons, including the fact that we cannot have at this time the CE certification, and therefore we are forced to sell the machine as a kit from one side, and from the other side also the willingness to make workshops out of it, to teach people how to build the machine, and you know, that people can learn more about mechanical design, electronics, and so on, and maybe in the future could build machines around on their own. So with these two let's say things in mind, we discussed, and we decided to make the documentation for people to build this machine. So we are basically making the assembly manual for this machine, but in this case, the documentation has been taking an approach which is much more structured than the approach of before. First of all, because finally I can detach myself a bit from the documentation. I can outsource the documentation to a team of people, which I also believe when things are scaling up, it should be the case, because if you focus on the hardware, you know, it's very difficult for you to also make a complete, proper documentation, especially for people that doesn't have experience. So there is also this communicational gap that you have. So I'm making the hardware, I'm producing and working with the software and the research about how to make this machine. But then my colleagues, Mark and Lian, are basically taking care of other things. So for example, Mark is taking care of making the workshops with schools, is developing the manual, is also looking into certification now, while Lian is designing the manual. She also designed the website, the branding, and so on. So let's have a look to how we design the documentation of Fabulaser Mini. Mark and Lian, are you here?
Yep.
Yeah. All right. Would you like to take over your parts?
I can take over.
All right. Okay. So
okay.
Sure. So the first step in making a whole documentation starts from the CAD. So to model this machine, it was quite quick, but to give the proper name to each part with for example, the screws. For example, the screws. Okay, you would call many screws of this design cap screws, you know, but they are DIN 912 and 610 millimeters. For example, you would call, for example, the different bearings with the sides and so on, but you call them with the item number and so on. So those that you see on the screen are just the screws of the machine, and I've used as many tools as possible, in this case in Fusion 360, to simplify the work. So naming is of course something. Then you have the grouping, for example, the things to count. So the numbers that you see in the groups here are the number of the items. Otherwise you would count all the screws, you know, by hand. Then things are of course grouped logically in terms also of subassembly. So you have a subassembly for the frame, a subassembly for the x-axis, a subassembly for the y-axis, and so on. And really, guys, to reorganize a machine that has more than 200 parts, you know, it takes a lot of time. So you can model it. Maybe you can export the file for production. You will make one prototype, but then to make this organized and very well structured, it takes a lot of time. So the documentation starts from here. And why it starts from here? Because from the CAD, we can, of course, think about exporting the bill of material. So this is something that, unfortunately, because Fusion is rather fresh in this aspect, is not built in. But if you scan the QR code, you will see there are plugins that allow you to export the BOM. So in order to create the first BOM of the machine, I was basically dividing the machine in some assemblies or sections. For example, this is the section about the housing. And then I was exporting the bill of material directly from the CAD. And then thanks to this, I was having a starting bill of material, an initial bill of material. Of course, the bill of material is something that later on you would rework manually. So this is a screenshot
Daniele, may I interrupt? There is some background noise. Somebody having a background noise and has to mute. Ah, now it ended.
All right.
Okay.
It's still there? All right. So the bill of material, guys, is the holy grail, the source of information for, of course, many aspects of machine production. Of course, it's used to order the parts, it's used to group shipping, I use it also for production because I divide my bill of material in different sections. For example, I have CNC mill parts, I have all the fasteners, I have laser cut parts, I have 3D printed parts, and so on. But it's also used for documentation, of course, because the naming, again, it's something that you would use to communicate to people what are the components. So in this case, for example, you can see the first column is the manual name, which is a name that it doesn't state the item number or the specification, but it's a common name that people it's supposed to be able to understand. It's also a compact name, like B screw stands for button head screws, T nuts, hammer nuts, washer. So the washers, for example, are DIN 125. You can also find ISO 7930 or something washers, you know, but in this case, the washers are only washers, for example, M6, M5, and so on. So in this case, it's because we have only one kind of object, and in this case, what we do is we will try to let people don't get confused, and we unify in a unique way identify the objects. So many other things have to be said about the BOM. For example, vendors, once you need to produce a machine, you know, you need to check your stock. And then we made another BOM for the stock. So we keep how many stock we have. We have multiple vendor lists in case one vendor is not available. There is another one. We were testing new, I was testing new vendors. For example, to improve the quality, I was grouping the shipping to save time and so on. All right, then the other step for the kit, for the documentation is the production of the kit. So you have your CAD, you have your bill of material, you ordered everything. Now is your time for producing the kit. So this screenshot summarizes more or less the kit of the machine, and you can see there are some ready-made parts, but also several CNC mill aluminum parts over here. All the housing, for example, is also CNC mill. You have laser cut parts, 3D printed parts, and so on. So the manufacturing of the kit is useful because you're going to check the parts and to assemble the parts yourself later in order to evaluate how you should write the steps to assemble the machine. So once you produce the kit, which is already a lot of effort, you assemble the machine. So we did assemble with our team the machine, and this took something like 2 months to assemble the first machine. And my team was taking notes of each step of what we were doing. At the beginning, it was just me describing what the steps should be. And then we all brainstormed the logical way of how the machine should be assembled. So as you can see, this documentation took much longer and includes many other steps and structures in comparison to the documentation that we do, for example, in Fab Academy, or documentation we do for a single project or a simple project. So all of this has been translated into a sort of logical structure of the steps to build the assembly manual. So we were basically defining what each step is with the title of the step that describes the operation to be done. We were timing the single operations that have to be executed in order to do that assembly. We were listing the parts that were needed for that step, listing the tools, and then had details and remarks about the assembly procedure. So this is basically our source file for the logical structure of the manual. All right, and now I'll leave the floor to Mark, which he will talk about the steps, the further steps.
Okay, but maybe there's someone who is unmuted, and that creates a lot of background noise. I don't know who it is, but maybe everybody can check if they are muted. So there's not this background noise is gone.
I think it's Thomas.
Okay, I'm going to mute these people. 1 second.
I think it's from Daniele's roof.
Ah, it's your roof, Daniele.
It could be my workshop roof. Yeah, now I'm mute,
man.
so it's fine.
Yeah. Okay, the sun is shining and then the metal is expanding. Yeah, it sounded familiar. Okay, hello everybody. I'm Mark Kolen, and I work in the Fab Lab in Kamp-Lintfort, and my job is creating workshops for children. So the children will have some experience in our Fab Lab, and they also learn things about machines, electronics, software, creating things, building things, using tools, all that kind of stuff, maker technologies. And as all of you, I also in my life used a lot of things, manuals to build things, and most of them are shitty. And we all know them. There are some are good, but most of them are really badly done. And that's what annoyed me. And then I just thought about it. How can I make an assembly manual which I would use and I would be happy to use? So what I did, I looked at what happened before in painting and drawing. And what I really liked is this kind of clear line of things. So no shaded views or any kind of trickery, just simple clear lines. I don't know if I can share my screen for a moment. Danielle,
You can try. I don't know if it's disabled by the host. Try.
you disabled it.
No, it's not by me. It's
Okay.
preset. I don't know. Give me a second.
Okay, then I will not share it. I had some examples. I looked at etchings from the 16th century. I looked at Japanese etchings. Hokusai is very famous for it. I look at comics. There's a style in comics. It's from the lowlands, Belgium, Holland, France. It's called the clear line. We all know Tintin or Kuifje, how it's called, or Tin or Tim. And I really like those clear lines because there's nothing extra. It's just a line, and the line explains everything. There's no bullshit, and you can see immediately because of a few lines what is meant. And the motto would be that less is more. We all know the IKEA manual, and in the past they are really bad. They're getting better all the time, and that's a very good example how a good manual would look like. But in this case, we are not building a cabinet, we are building a laser cutter, and that's a little bit extra. And I'm a very enthusiastic Rhino user since 2000, so I'm doing it for a long time now. And Rhino, yeah, you go to the first one with Rhino. Rhino has some options to get a real nice workflow. So we had to go into it and decided what display we would use. And I created in Rhino all kinds of options to get a clear line. But first I had to deal with the file Danielle made in, I think you made it in Fusion 360, Danielle, is that right?
Yeah.
Okay, and he handed me that file. It's a step file, STEP file, which is a common file format to interchange 3D files. And the thing is, if you make it in Fusion 360, all the parts like screws, you will not draw each screw separately. You will have one screw and you multiply it. And each time you multiply that screw, it becomes like a block instance. It's like a virtual link to the mother screw. And you have to explode those views. You have to get rid of those links and make sure you have that one screw and its 100 children, make them like individual objects. In Rhino, there's a plugin which take care of that. It will explode all the blocks and makes it into individual objects. And it even takes care of the layer state, which is made in Fusion 360. But Danielle, of course, he designed the machine in his way. So he had it all grouped in the different parts. So he had one group only for the fasteners. He had one group only for the casings. He had one group for the electronics. So what I had to do is split all those objects up in different layers and sort them out according to the steps we want to use for the machine. And in this picture, you can see the second step. It will be the corner profiles. And the previous step was the bottom frame. The bottom frame is our 5 profiles with brackets and screws. And that will be the first step. And the second step will be the corner profiles, those 4 vertical and z-axis pointing profiles accompanying with brackets and screws. So the idea was the previous step should be white and the actual step should be black. And as you can see, they are all in very simple lines, showing not too much, only the necessary thing. Can you go to the next one? And I can also sort it out in the different views. So we would have a main view from all of it, and I can save that because Rhino has the option to do all these kind of different things in different tabs and save them. So all the steps, views are saved in the view tab. And as you can see here, the screws are out. An exploded view, which a lot of CAD programs have, it won't work because you cannot make it too precise, and you cannot steer it too much. And in this case, you can just move one object and you can save that as a named position. Maybe you can go to the next step, Danielle. We are missing some of that, but that's not bad. So can you go to the previous? Once we sorted out the different steps with the accompanying objects, we can move them, and then with this thing, what we're seeing here, this view, it's all saved. The positions are saved, and then we need a 2D drawing of it. And now we can go to the next step, Danielle. And for this, Rhino has a 2D drawing option. So what it does, everything which I select, which is yellow here, it will save as a 2D drawing, as a vector drawing. And that's really nice because if I would make a screenshot and if I would go zooming in, I would, as a screenshot, I would get a pixel file. And the pixel file, it's too blurry. If I go into it, it will get blurred. And it doesn't take care of details. Also a really fine line, it will look more like a stair as it will look like a line. So what it does, it makes actually vector drawings. And that's really interesting because if I would export it as a vector drawing, as a SVG or as a PDF, I could zoom in unendlessly, but the line will still be a really nice sharp line. Except of course, the resolution of your screen will at a certain point can make it like a stairs. Anyway, Rhino has that option. So in each step, I would make this 2D drawing of that particular step and then save it. Can you go to the next one? And I save it and I put it in a different file in Rhino because of all these different steps and objects and layer states and named positions and named views, the file gets bigger and bigger. And at a certain point, it gets so big, and with my laptop, it gets really slow. So I took out all of the vector illustrations for each step, and I organized them in a different file. It's also a good practice because if something goes wrong with one file, you still have the other one left. So then not all of your work is gone, which is, of course, also a prayer for good backup strategies. We all know that. We all had that experience that things break down and a whole year work is lost. So guys, please think of good backup strategies. So we have here this file with only the vector drawings, and we're not there yet. We have to go to the next step. Daniel, I would choose a file and then I would save it as a PDF. PDF takes these vectors as vectors. So they will be vectors inside a PDF. Can you go to the next one, Daniele? And once we have PDF, it can be important in every vector-based program. That can be Inkscape, that can be Illustrator, InDesign, you will name it. And now my part is done, and I can be going to Lian's part, if Lian would like to.
Yep, okay. So once I get the vectors, I usually use Illustrator because I am more familiar with it, but any vector software will do. I control the line width, so you can see here, yeah, it's not selected, but it's it's a controlled line width. I control the sizing, and I have a artboard. This is only for the icons. And then I saved all of it individually as individual files with the names. You can go to the next one. And for the illustrations, I also have a predefined artboard. So that's the limit of my drawing. And so again, I changed the color as I wish because Mark exports in white, and we defined that it should be a shade of gray. I defined the line width, and I separated in groups the vector, so it's easier to control. You can go to the next one. And then the manual is actually created in InDesign because InDesign is a proper software to create editorial designs such as magazines and books. So it has many features to automate, for example, typography, page margins, columns, and many other things. That's why I use InDesign. So then I created a master template of the page, which has the title. You can see there where there's a icon of a clock is where the timing will be, the number of the steps. On the left side is the list of parts needed, and below is the list of tools needed. So every step will fit in this template. Can go to the next one. And then I create page by page, importing the illustrations from Illustrator. And what's nice about it is that I can easily find the name of the file is very important, and I can easily find this illustration if anything needs to be changed. I go directly to Illustrator, save it again, and change directly in InDesign. And also the icons, as you can see on the left, they are all linked. So if I change one icon, it changes in all the pages. And we use these bubbles to show details of things that need to be paid attention to. And basically that's it.
Would you like guys to talk over the manual itself, or shall I do it?
You can do it.
All right. So after all these steps, of course, it's not up to us to define, the complete procedure. It has to go through a testing stage where other people will build it. We use our instructions, and we will see what is the feedback onto it. And we all think differently, and once people that doesn't have any experience, tries to build this machine, there are many different points of views of things that were not clear and so on. So we did run 2 workshops. The first one was held even remotely in Fab Lab Benfica in Portugal. And it was quite difficult because of the distance, of course, and also because it was the first time that people were building this machine, apart from us. And then on the right side, we also ran a workshop into a school where not so expert people would try to build it, and they gave us both a lot of feedback. So for example, things that were not clear, errors in production, and so on. So with this feedback, we were basically going back to any of the previous steps. So we could go back to the workbook. Okay, there is a logical error. We go back to the Rhino steps. We will go back to the production, to Fusion, to the packing. Even there were labels that were not clear, for example, and time that was not clear, screws that were not okay, or steps that can be swapped, and so on. So integrating the feedback, it's also something very important and really huge. And it did change it quite some. Here you can see a screenshot about our action list, where you can see that you can basically redirect the feedback to any of the things that needs to be changed. And this, it's also huge work. So, and finally we have the assembly manual of Fabulaser, which, as Liane just told me today, it's actually the new version, just finished now. So before we were working with drafts and with partial documentation, but this is a preview on how it looks like. So at the beginning, we also talk about the tools that we need, that and Liane and Mark made all the icons for it, some tools, some special tools, some templates to align the linear guides, for example, and to make square the profiles are already included, like the templates. Some other tools you have to bring yourself. At the beginning, we also added a lot of little addendums that would explain people even the simple operations. So, for example, how to put TNAT into the profile, for example, or how to slide it in if it's open from the side and it's convenient for you to have it. Of course, we were also talking about the more complex stuff. For example, how to rotate the knobs of the laser calibration in order to redirect the laser during the laser calibration, and then also how this would affect the calibration and so on. And then we start with the steps. So the manual is divided in steps, and each step could have or not sub-steps. So each step is basically a logical assembly of the machine, and each sub-step subdivides the steps into a logical structure. So this is an example of a step that includes the electronics wiring. So in this case, you can see we use different colors for different cables, and we were also showing like the components that needs to be wired, how they should be wired, and also if some cable needs to be passed somewhere in the machine. So in the bottom, there is the schema where you can see the logic connections. On the top, you can see where the cable should pass, okay? Or you can also see how many cores the cable has, and which colors the cable has. So in the kit, we are also providing all the cables crimped, so the user doesn't need to solder anything to assemble the machine. All the cables are ready-made, and they are labeled individually, so you can straight away connect the things. So here a step about the mechanical assembly with several pop-ups. So you can see here a little bit more also about the structure of the single page of the single step. So you have on the left side all the parts that are needed, on the bottom the tools, and some pop-ups that shows like the magnifying glass of some specific areas, and also the different remarks that you should follow. It's worth to mention also that, as Liane did in Illustrator, some things are shaded, some things are in black, just to indicate to the user which areas or which items are being assembled or worked at this time. So here another step about assembling the y-axis motor, and another feedback that we receive, for example, that even though this manual doesn't have much text, people doesn't read text. So we need to find ways, even more ways, you know, to communicate in an intuitive way to how to assemble different parts and different things. This, for example, about the laser calibration. So, for example, the order of the tests that you need to make in order to calibrate the laser, and so on. So we also had the section about troubleshooting, where we were discussing the simplest issues that could happen and how they could be solved. So we try really to complete and fill every small gap of people being able to replicate the laser cutter. All right, and that's basically it. So now we can open the discussion. I just have a mention that we're going to have another workshop on Thursday where we will show the design of the different machines that we've been making for another project together with Professor William McGill, which is also in the call right now. And this will be on Thursday at 9:30 chess time. All right, thanks a lot. And I think now we can answer the all questions that are in the chat and put the questions that are coming. Okay, I will go to the chat now, and then we will see the single questions since the beginning. Sorry for the noise, guys. Okay, Leopold, are you there?
Yes, I'm there.
You asked which software did you use for documenting the machines. I think this question was answered along the presentation.
Yeah, that's true. But my follow-on question is, which proprietary software is unavoidable for efficient documentation?
So it's basically, I would say, all of it. So you can avoid all the proprietary documentation. However, and I'm telling you by experience of making many machines, there's difference between what you could and can do in a specific time and what you need to do, you know, following the deadline, and what you can, you know, let's say, achieve in reality. So we started by using an approach like, okay, let's do it whatever tool we need at that time. The goal at this time, the goal was like, do it, make it. I'm also, of course, like releasing most of the machines as open source. So I cannot avoid to say that, of course, closed tools are not nice. But on the other hand, because they're not open source, but on the other hand, if they make you do things quicker, faster, and easier to release the machine and to make a laser cutter for real, you know, then at this time we used it. So that's why we didn't use all open source software. Also because there was lots of previous knowledge about this software that we have accumulated along the years. And, you know, I know how to use FreeCAD. I teach to my students as well, you know. But for example, when it comes to CAM, so I need to manufacture the kit, just to say something, or comes to assembly, for example, and so on, all these things would have slowed me down, unfortunately, because of this difference in knowledge that I have, but also things that are still missing in some open source software. So at this time, I wouldn't have a finished laser cutter, unfortunately. It's something sad to say, and surely I will try to switch as much as I can towards open source software. But if in FreeCAD, I don't have a CAM software that allows me to produce the parts that I need for the machine, you know? And so I know there are different opinions and different things, but we needed to make it so. Sorry to be so long. Leopold, do you have more questions, or we go to the next questions?
Just one more question. Yesterday, SolidWorks made an offer to Fab Labs, which seems to be affordable. Do you think that's usable for documentation?
So for sure, for example, I know that SolidWorks is having much more mature features in terms of standard mechanical engineering, including the exporting of a nice bill of material, for example, you know, and but for example, if this doesn't include the CAM, if it includes only the software but not the CAM to cut the files, to cut the pieces, for example, so this is again another stop. So it could improve, yes, yeah.
Thank you.
All right, Mitale Parik.
Before you go on, Daniele,
Yeah.
just following on from Leopold's comment, does SolidWorks in fact include CAM? Does anybody know? My understanding is there is no CAM available in SOLIDWORKS. You got to pay the extra 5 digits to get a CAM license. Does that offer from Dassault include a CAM of some kind?
I have the same guess, and I think the answer is no, to be honest, as far as I know, but we have to look into it. All right, I think there was a question from Mitali Parik.
Yeah, that's me. Hi. So so you know, sometimes when you buy parts, you need to buy them in bulk. You can't just get like a couple that you need. For example, if you need a particular part X, 3 quantities for the whole build, but sometimes you just have to buy a pack of 50 because that's what's available, right? And then after you finish, you just end up with like a lot more parts, and like a project which has like 200 or 300 parts like yours does, there's it kind of adds up at the end, you know, in quantity as well and in cost as well. So how do you factor that in?
So the first advantage, let's say, that I took into consideration is to be in Germany, because in Germany, many mechanical parts are even sold like singularly, like one by one, or in very small lots. So in this case, the adds up at the end, it's very small, because if you need to order, if you need, I don't know, 15 parts, you need to order 20, then 2 are left over. And then you can clearly reuse that leftover for a sort of continuous production. So all the leftover is basically placed into the next machine. So basically what I do is I hold her in stock, a huge stock. For example, I just produce right now 6 kits for 6 machines. So I make all the, let's say, combination in the shopping carts. I have all the shopping carts saved for one kit. And then what I do, I multiply this for multiple kits, and then I try to reduce at this point still manually all the heads up. And,
sorry, I misunderstood. So when you send the manual, you send it with a kit including all the parts.
Yeah, the kit is including everything apart from the tools, like screwdrivers and Allen keys and so on. So it's including all the screws, is included. Yeah, one problem of replicating the machine is also like for people to purchase the parts. So for this machine, you know, a bill of material for different continents should be made, like one for US, one for Germany, one for. So one problem is, where do you find all these specialized parts? So okay, screws maybe are easy to find, but think about, for example, the laser mirrors, or the lens, or the laser tube, you know, or the maybe some things are manufactured in some countries, some things are manufactured not in that countries. Yeah, the kit includes everything. And when we buy things at this point, still manually, we try to buy in a way that is convenient, that there's not much left over.
Yeah, thanks. That makes sense. I was thinking with the point of view for the end user who might have to buy a weird number, but if the kit includes everything, it makes sense.
I mean, some things are very hard to buy, not only because they are difficult to find, also because maybe you need to import them.
Exactly.
And this is another procedure. So what we did is we structured ourselves to be an official importer in Germany, let's say, so it's easier for us to order the tubes.
Yeah.
For example, you know, but for normal people, it's, for some countries, impossible. For example, when I was working in UAE, in Dubai, the profiles were simply not there, you know, and they had to go.
Maybe that's why the question, sorry to interrupt, maybe that's why the question came up, because I'm right now here in Fab Lab UAE, and it is very difficult to find some parts.
Yeah, so for instance, the aluminum profiles were undergoing nuclear inspection by the customs. Yeah. Because aluminum could be used to build, just to tell you, so it's very difficult. So what we do is we pack everything together, we ship this to the customer. So even in Portugal, which is in Europe, many of these parts were hard to find. Right. You know, so you see all the little bags here behind, they're all full of these. So, and there is a huge work in packing, because every item is packed singularly and labeled singularly. You know, so we have also all efficient work for labeling and so on.
Okay, cool.
Maybe I can interrupt for a moment, because what I can contribute to it. what Daniele just said. He showed the bill of materials, and then he talked about the packing as one topic, which is in building a manual and documentation, which is important, is to have continuity and corporate identity. That means that when a screw is called B screw M3, that on all the different platforms, the same name should be used. So we have, for instance, we have the bill of materials. We have our workbook for the different steps. I have all the layers in Rhino. Liane has her InDesign with all the text and the tools. So you have to take care that you're always using the same names for the objects. Otherwise, you get confused. Danielle has to use, I don't know what you use. You're using a Word document for the packaging, for the labeling, Danielle?
No, I was actually going to Drive to show some in work pictures.
Okay.
One for the kit and one for the labeling. So for the labeling, basically I use square labels that you can buy like in A4 sheets. And then I have a document in Google Docs where I have all the labels, and I print this for all the kits. So I will show you maybe the labeling.
So when we started doing the manual, we didn't know anything. So we had to improvise, and Google Docs provided a real good means. In the next step, I can imagine if everything would be somehow connected, if you change the name on one platform, that it automatically changes in all the others. That would be really convenient, and that would also take care if in making less mistakes.
All right, shall we go to the next question? There was a question still for you, from you, Mitali Parik.
Yeah, about
the
the time.
Include time to prepare parts and tools. So my feeling is that because of the huge amount of parts that we're shipping to the customers, you know that a job is also for the customer to search into the parts. So we ship the parts separated in boxes. Of course, we have electronics, hydraulics, mechanics, and so on. But there are many, and if the user is not organized, he places everything on a table, you know, and he has to search through the parts. And if you put the things together, then to search a single part, you lose like 5 minutes for each, you know. So this part has not been included into the manual. Maybe Mark or Liane, you can correct me if I'm wrong.
Another sub question. So like when you package the kit itself, are there like packages inside the kit that go stepwise, or is it according like all the fasteners together, all the mechanical parts together, all the electronics?
It's the second option, because to pack every single part according to the steps, it's much effort. It's already much effort to pack 200 parts.
Yeah.
You know, I label them singularly by hand. You know, we are not Airbus here that will build the airplane with all the supply chain and so on. So you're like, it's one-man business and two team members.
Yeah.
Yeah. So I'm going to share the picture of the, if I find it, yeah, of the kit, because it's huge. Meantime, we can also go to the next question. Okay, Chris, you mentioned that you can do everything with FreeCAD, Inkscape, and Scribus these days.
Oh yeah, so last year I've been doing a lot of things with FreeCAD, and I discovered that it has a really nice TechDraw workbench. So where you can, make cross sections of the machines or objects that you design, and then you can also modify the lines, and you can export nice drawings. It's so there's you can export PDFs and SVGs, so, and for documentation for purpose that would be just enough. But for example, I faced some issues when I exporting drawings for laser cutting, so it's not really nice in terms of connecting lines and grouping geometrical objects together. But but it seems that they are getting forward really quickly. And I think if just for the sake of experiment, if somebody somewhere has extra time, maybe me, I could just try to remodel one of the smaller machines and try to kind of go through the process to understand where there could be problems and what is that cannot be done these days with open source software. But I also understand that you made good points about the time. So if you need to get to the results faster, then you probably are going to use whatever you have the most experience with, like Fusion 360 and Rhino and then the Illustrator, because you are not going to have extra time to learn new software. It took some time for me also to kind of dive through to get introduced myself to FreeCAD. So instead of, let's say I could do a thing in a week with Fusion 360, but with FreeCAD, it took almost 2, maybe 3 weeks, because I had to kind of get familiar with the tools and find the correct workflow. But what I can say is that FreeCAD is getting better. Don't be afraid of it. It's going to be there soon.
So one comment about this, Chris, and about you, Mark, is that there are, of course, huge open source initiatives in the world, apart, of course, from Fab Academy, one of which is Fab City Hamburg. And we hope, I personally hope to get involved in this project a lot. And in this project, there is going to be hopefully also like some funding for the inventor of FreeCAD to develop automatic mechanisms to help documentation, which means, for example, if you have something, if you have a body in the FreeCAD and you change the name, this should automatically change in the bill of material. They want to create these models that will propagate the changes from the CAD to anywhere, and this is one thing that they want to do. And the other thing that they want to do is, of course, improve the CAM to be fully 3D, for example, and all this kind of stuff. So we hope that this could bridge the gap between this.
One question about CAM. So what are exactly the features that you are looking for, so that you are missing from other platforms?
So one feature is, of course, 3D milling, full 3D milling, because the laser head is a fully 3D model, and I need to mill it fully in 3D. That's one thing. The other thing about the CAM is relative to the CAM. So now there is this function which nests all together from Fusion. And this is something that I need to use a lot when I need to produce the panels, the panels of the laser cutter, the housing. And also I need to specify exactly the entry point and the exit point of the end mill to avoid that the debond will move over. So I completely arrange the strategy by hand to make sure that the parts, while the cut is running, they will not come up, you know, and from the fixing, because they are basically not fixed on the bottom; they're only fixed on the side. So if you cut in the middle, these parts can leave. And basically, I cut always where there is the most stable point for the parts. So this is all these fine-tuning details that I miss in FreeCAD are also important. And then, for the laser cutting, that's another thing, because I also have laser cut parts and the lines are not joined and so on. This would require some rework in another software to close the lines, to make it properly. In Fusion, I can just make a projection, export the sketch, and that's ready basically for laser cutting, Chris. Yeah, so, and other than that, sometimes there are some errors in the CAM from FreeCAD. You can correct me if I'm wrong. And you know, each panel that I cut, it's €100. So if there is a bug or a problem or something, it's, yeah. And this machine, we don't get much income actually from this machine. So we have to be stable, solid to survive at this time. All right, I think there are no more questions.
To continue that discussion, Daniele, the CAM out of Fusion isn't perfect either. I have scrapped a number of jobs where the export from Fusion hasn't been perfect. So I think they all have their bugs, but it comes down to whose you like best and what you're most familiar with, and what your post processor does. So have you got the right post processor for your particular machine? So far, for the machines we're using, Fusion works. Yeah, that would be interesting to see what comes of this new idea on how to do the CAM. But that's not the point of this workshop. This workshop's really more about the rest of it. So.
All right, I'm going to share the screen. I hope I can show you some pictures about the. Okay, there is somebody joining now. Okay, that's good.
Can I just comment?
Please.
This is an impressive work you guys have done. I mean, you basically elaborated a system how to document the assembly of a working kit. I mean, starting from the kit itself up to the point that you guys documenting, and also the user perspective. I'm sure that there have been quite some hours done into this work. So yeah, it's quite impressive. It's nice to watch that in progress.
Thanks, Christian. So this is one of the first kits that we have delivered. So it's all basically packed. Unfortunately, I don't find the picture where I have like 6 tables with all the kit flat, because if you lay the kit flat, it's 6 tables, guys, of parts, And but here you can see some examples. Everything is labeled, is grouped together. All the parts are already pre-cut, pre-smooth, and so on. So the kit delivery, guys, includes many steps. Also, for example, quality checks. So, for example, I delivered a machine to Professor McGill, and there was a part that wasn't smoothed, and there were some problems. So I had to took the parts back and change them, and this could happen to customers. And we are small, so if this happens to lots of customers, they are going to destroy us with requests and so on. So we are trying to improve our quality check. So this is, for example, the old kit. Yeah. So for example, other difficulties that the parts are not labeled on them directly. Some are like big parts, but some are labeled in a bag. So once you take out the part from the bag, what is this part? You're lost, So it's yeah. And so we have also lots of checkings that we do. So wait, this is, for example, the file for the labels. So we'll basically print this label, the square labels, and then the square labels you can basically take it and you can put it on the parts. And these labels corresponds to the manual name. So you see, if a name changes in the BOM, then it changes in this file, then it changes in the manual, then it changes in the workbook, then it changes, and and so every change must be done correctly. And we are actually having some mistakes, sometimes some mismatch, which we hate, by the way, mismatch in the naming, and this causes confusion into the customer. Before the kit is delivered, there are some pre-checks. Let me see if I found this. Yeah. So, for example, some parts, are so some parts are ready-made. Some parts are fabricated by us entirely. Some parts are modified by us. So, for example, you need a hole in the head. So, what if you forget this hole? You need a drilled 4.5 millimeter hole in the head. For example, you need to check the tubes. So we had some kind of weird random problems that it's because of the number of parts, which are very difficult to track. For example, we had dust inside the silicone tubes, and people got the dust inside the laser tube, and the machine could not work. So now we are checking every tube if there is dust inside, or we are changing the supplier. Sometimes the supplier also creates us these problems. So, for example, we need to crimp both sides of the laser plus, crimp laser minus or laser plus, then check the T-nuts if they hold correctly into the bed. Some T-nuts are defective, 1/100, what to do? So we give 10% extra to the customer to make sure that he has the parts to build it and so on. So, by the way, also a huge lesson to learn from this is basically, guys, relative to the design itself of the machine. That we will talk more about this into the other workshop. But here I can show you maybe some stuff also about the Kamp and so on. That is actually how many parts do you need for your machine. You know, the more parts, the more time you need for labeling it, producing it, checking it, putting them in the manual, and so on. And one question that we have is also like, okay, I want to make this machine something that other Fab Labs can replicate. So I should not use a laser cut bended steel, which would save me of these 200 screws that I need to use now to join the profile to make the frame. So there are lots of also philosophical questions about how you can optimize really the design. And here, for example, is the Kamp. So now for the Kamp, guys, I don't do anything. I just, you know, launch the files. I have 3 plates. My supplier provides me these plates already pre-cut. I buy exactly the number of plates that I need. Then I press play in the CNC, and that's all. So one day I can cut like 20 sheets, but it's going to be still very, very hard. It's something all this organization that I miss in other software as well. I think it takes some time to load the Kamp.
If you would make a ratio, the time it took for you to actually make your first prototype, working prototype, and the time it took for you to document the entire process, time-wise, what took more in terms of time?
All right, now we have to another problem. So there were actually some points in the open discussion that we could discuss, but this is actually one of the things I would like to also to ask you. By the way, these are just to show you the different setups. They're already made and nested to don't fly. Yeah. All right. For which regards your question, Christian, so there is a huge problem, which is the following. To make a single laser cutter that works and to impress others with this, it's a matter of weeks, you know. For me, with the previous experience, just to make it, it's very fast. But to document and to make the process structure, it takes months. To industrialize the process, you know, for production, even optimize, because if I have to make one, I have this scrap part, I have this spare debond, I have alpha plate that remains from an old job, okay, we use it. I have this piece of aluminum, okay, we use it. I buy these things 3 months ago, but the supply disappeared because it was in Amazon. No, you need stable suppliers, you know, to supply. So, and then the other problem is that the hardware development, it takes much less than the documentation. But this, I have to say also, it's because of, I think, financial resources. Because maybe we need to have more time to dedicate to this, while we also have other jobs to do, of course, in university and so on. But just to give you an idea, I think the machine took like maybe 3 or 4 months. The documentation took longer than this. Yeah, much longer than this. I think documentation is something that is taking like 8 months or something. Yeah, but also depends on the effort. Sorry, yeah.
No, it's we have to think that the idea of making the manual was to ship it as a kit together with the machine, so it should be error-proof. And a laser cutter is not something easy to do, and if you misalign something, the laser cutter is not gonna work so well. So to properly instruct someone to build from scratch, and yeah, it's not something that should be overlooked on the steps. So we have to be very precise in every step to make something very usable.
I'm looking forward to buy one kit myself to test it and give you some feedback.
Yes, please.
All
Yeah,
right,
just when you give the feedback, you have to be a little bit gentle.
Yeah, another problem, guys, that you might feel is the following, because you invest so much time in the documentation, you invest so much time in the hardware development, and you know that a laser cutter is a complex machine. It has a laser light that needs to be calibrated precisely, otherwise you're not going to cut anything. It has a precise control system. It has lots of interferences because the laser works at 10 kilovolts or so, you know? And you spend lots and lots of time, but still that machine is not, of course, perfect or good. So once you deliver to the customer, you need to have hard stomach to, after all this hard work, to get the feedback. But it's something that you need to do. It's very important, and the customers are really some customers are really gentle with us and really open-minded. Otherwise, it will not be possible. All right, there are more questions because there were some points about open discussion as well. If you want to.
I have a question. Can I find the documentation on GitHub somewhere?
So this machine, guys, is still not published. And there is also the discussion to publish it or not. I would like to discuss it with my team. One of the reasons is that the laser cutter is a very dangerous machine. And my drone documentation was used a long time ago by a Fab Lab in Rwanda. And this guy, after a while, he cut a little bit his fingers with the drone. And we don't want people to get killed by the laser cutter or get blind. So it's something, you know, a little bit critical, also in terms of responsibility. So we didn't publish it yet. And then also because we are trying for now to get a little income from this machine. And we want to be sure that everything is also correct and 100% checked from this. So for example, if these open source initiatives will help us, or this project like this one that William is running is actually helping us a lot, I have to say, we have to discuss with our team. Yeah. So well, sorry.
Okay. Well, one of the next workshops is about mainstreaming open source hardware. So maybe you should attend.
I'm already listed. Yeah, open source hardware should. Oh, sorry, William.
Yeah, I was just saying that the important thing that Inger, I'm sorry if I'm mispronouncing your name, but the two of us are both very interested in and want to continue to support you in developing a manual for manuals. You know, what the step-by-step process you just took us through in this workshop would be really, really useful if you guys would document your documentation process. I mean, that would be really, really useful for the rest of us who are, you know, we're not quite that far along, but it would be really, really cool, I think, for all of us to see a documented documentation process. So I would very strongly, and I see Inger shouting in the comments, yes, please, yes, please, yes, please. So if you get a chance at some point, without having to go through all the detail of what's in your documentation, but just showing us the steps you did in a documentation format would be fabulous.
Yeah, and that's one of the points of these open source initiatives, that if they get enough fundings, this is exactly what they want. They want the experts to do the meta documentation of the projects. Yeah, and another thing that is very important that these initiatives are also taken into account is thank you, Leopold, is the sustainability of the projects. So how, you know, this can be sustainable in a way that, you know, me, Lian, and Mark can get some stable income to work on this project. Because as far as I can tell you guys, it has been very hard. You know, it has been like weekends and nights and to make this machine working, and as well the guys to make the documentation. So another point would be how to make open source hardware generate profits. So some approaches were to use sort of fees that people could pay you if they replicate the design, for example. But we need also sort of blockchain controlling this process, because, you know, I've seen, you just go to an AliExpress and you see many boards published on GitHub being sold without mentioning anything or anybody, for example. So, and on the other hand, we also need to survive. This aspect is important. So that's why sometimes closed source software, that's why we still haven't published this machine and so on. Yeah. All right, I think the time is.
Time is up, and all I can say on behalf of us all, congratulations on an absolutely fabulous machine and documentation. All three of you have done an absolutely fabulous job. So thank you very much for sharing that with us.
Thanks, William.
Thank you, Daniele, Liane, and Mark.
There was a question about another question, I think, that just came. Offer outsourcing. Inger, you can talk if you want.
Maybe you can make some money by offering. You make documentation for other projects, just for you to make some money once that you have find out how to do it.
I see. Okay. Like if somebody else has another project, then we can document it.
Or you could offer a service as if like, how do you document your project from first step to the instruction as a product, for instance?
Well, I believe from some aspects, this process has been really well established in the industries. Also for startups, after certain limits, there are industrialization, sourcing, and well, maybe about the production, but maybe not much about the documentation. So from this aspect, we think that we are creating something unique because there isn't any other open source machine so well documented, I would say, and so complex. I mean, there is Prusa that is documenting also their machines, and like another laser from Netherlands, even though it's not very well documented. But this could be a service for sure. Yeah, this could be a service. Yeah, but then we shift a little bit because maybe that project is not a laser cutter or a 3D printer. It's a product, but it's for sure useful to take all this meta documentation and deploy it into the Fab Lab community, so people can start making products out of Fab Labs, because that would be really, yeah. The next machine is going to be a standard format laser cutter for Professor McGill. It's already in design process, and we need a standard laser for Fab Labs because Fabulaser, guys, it's quite cool, but it's very small. So it can cut up to 10mm acrylic. For 40-watt laser is a good achievement. But the size isn't quite big enough to do some standard prototyping. So the next machine is going to be 1 meter times 700mm cutting area laser cutter, where all this feedback is going to be confluenced in order to have better mechanical design or easy to make manual and so on.
Daniele, a quick question. Have you tried video documentation before? Is that something that you have experience with, and how did you find it?
So I have personally tried some video documentation in the past for some projects, but only in small sections where a specific action was needed to be shown, which was very difficult, very hard to document it. I think now we are completely discarding the video option, at least in this stage, or maybe Mark and Jan, you can add more comments.
Yeah, well, the reason in the beginning we chose for this clear line type of manual was because it's a clear line and there's no other bullshit, shadows or whatsoever. And I had worked with other manuals like building a 3D printer, which the manual consisted out of pictures. And the problem with pictures is that it's subjective. The one who makes the picture has to choose from a perspective to make the picture to show how something is done. And maybe it's good, maybe it's bad, but it's also always very subjective. And you have to deal with light, with shadows, with colors, all that kind of things, which makes making pictures for a manual even more complicated. And I think the same thing will happen with a video. But Gianluca, what I was thinking of as a next step, which would be interesting to see if that's possible, I don't know, is to make animations where the user can choose the point of view to see what is actually happening. And I'm not quite sure how to do that, but I will investigate into that, because that then you get rid of all the subjectivity. You just have how to put a screw in something, and you have that as an animation. And if the viewer, the user, doesn't understand it from my kind of perspective, he can choose his own kind of perspective to see what is really happening. And I think that could improve in a very drastic way all kinds of manuals, or even use AR or VR, that you can use your mobile phone to hold it on your first step, which is the bottom frame. And then it will show you where to put the screws and the brackets. These kind of things I'm thinking of.
Yeah, I think a good example would be Lego instructions. I'm not sure if you use iPad recently to build Legos, but now they provide the 3D view, and you can scroll around and then you can move to the next step, and that kind of creates the animation directly in the 3D model to show where everything fits. And then you can turn it around and see exactly from a different perspective. So that would be a good idea, I think.
Yeah, that's a very good example.
I also find videos difficult to control, to follow up, because you lose a point and then you have to go back and then you lose again. And then I find it video slightly difficult as a manual.
We also had experiences, Gianluca, with another kit of laser cutter, which was documented by a video. And after, I think, 9 months, the laser cutter still stands in the lab, and we are not able to finish it. Because in the video, there were not many overlays or information or anything. But of course, I agree with all of you, a digitized interactive version of the manual will be great to have, with some input from the user as well, you know, not only like augmented reality. Well,
but it's gonna take much more time to prepare it.
Yeah, well, we have to see benefits and drawbacks. For now, our goal is just to make it and to have it. And then if we survive economically, eventually to step forward to all these things. And yeah.
I think you guys should give this lecture at the beginning of Fab Academy, at the beginning of every Fab Academy, when we talk about documentation in the first session. I think that new students should go through those so that they have them at least in their subconscious. So they start documenting in a good way from the start.
Yeah, well, I think this approach quite differs from Fab Academy because it's something highly structured and needs to work. In Fab Academy, we aim that somebody can replicate your work. But I don't know if a student without much fabrication experience could do that from the very start. But yes, well, you're right. So they feel the pressure as well. Yeah. So I have finally found the pictures of the kit. I don't know if you see this is basically the old kit, and this is like a video showing all these parts, right? And it's hell of work to do all these parts and make sure that everything works one by one. Yeah. All right, I think the time of the workshop is over by 10 minutes. But if there are more questions, okay. By Leopold. If there are more questions or more point of discussion, guys, you're free to join or to ask.
Well, I need to run. Thank you very much. That was brilliant. I'll look forward to seeing the next one of these.
Thanks, William.
Yeah.
Thanks, Thor, for your help.
Thank you, guys. It was very interesting. Thank you.
Thank you, guys. Bye-bye. Say well.
Bye.
Send me an email if you have help or questions. Bye-bye. Bye.
Bye-bye.